So good morning and welcome back to another round of Still Connect webinar. I'm Rocky and your host today for another round of to talk about steel and building related topics. As usual, if you have any questions, feel free to actually drop it down in the Q&A box at our side. Meanwhile, we'll have a couple of polling questions that will gain your collective feedback during the session. So for fellows architects or engineers, if you wish to claim your LAM CPD point or BM CPD hours, you may stay through the entire webinar to and a summary windows will pop up in the on your screen once you exit the webinar at the end, and you may fill up your LAM or BM membership number in the survey form. Right, so for our topics today, it will be about the difference between accelerated tests and also outdoor weathering tests. So in this section, I'll be covering the basics first, which will not be the main points, main topics that will build a background of this topic. So, and then I'll move into different types of accelerated tests or outdoor weathering tests. So let me just share with you why do we need to do all these tests in the first place. So outdoor components, as you can see from all these, like outdoor aircon units or even satellite buildings and satellite components, they go through day-to-day weathering effects. So over time, they will get rusted, and this rust itself, is what the material is supposed to withstand, from a day-to-day weathering. So of course, over time, if let's say paint, they are not durable, they will actually deteriorate over time. Same with the base material. So it will actually start rusting and so on. So it is especially crucial for components that are, durable or expected to last, for a very, very long time, to be very, very durable on the outdoor, right? In different kind of weathering exposure. So in order for us to actually prove that the material itself can withstand such weathering, there are different types of methods adopted by the industry to demonstrate such resistance towards the weathering effect, right? So of course, spoiler alert, on the title, there are two types. One is called accelerated weathering test. So here I show you two examples. One is called salt spray test, and another one is called UV test, right? So salt spray test is basically to induce the corrosion of a product, and UV is actually to weather off the paint surface to simulate so-called the sun exposure, because sun itself, as I mentioned in previous webinars, it actually emits out different kinds of rays, different kind of energy, from infrared to visible light to UV. Okay, so the UV one is the ones that cause the most damage to those paint layers. So that's why it needs to be used to simulate such a weathering effect. So in fact, both these kind of tests are referred to as accelerated tests because they are both simulated environment, as you can see in the chamber, and second, they would actually accelerate the effect, so-called induce the weathering condition of those samples in such chamber, right? So bear in mind, this session itself will be focusing about salt spray tests and also what are the equivalent tests they are. Of course, equivalent when you say is to induce corrosion. Of course, I will also be sharing what are the pros and cons of other tests, including salt spray tests. Of course, we will not be focusing on the UV test itself, also called the paint accelerated test or long-term tests. So that will be leaving it for other sessions. Right, so the test conducted, as I mentioned, is done in the chamber where you have different elements to induce so-called the environment, right? So for example, the salt spray test will you actually emit out salt mist to the environment to actually induce the saline environment. So basically to simulate so-called near sea environment. And for the one at the bottom you see here is to it so-called the UV test. So there are actually different components to be used. For example, the xenon lamp, it emits very closely to the sun emission, right? The sun UV emission, right? But there are actually a different kind of lamp to use in different types of UV tests, right? So at the end of the day, this kind of accelerated tests are considered a type of simulation, right? So when we say accelerated test, it can range from 1 month all the way to 6 months, but usually it will be from 1 to 3 months, and 6 months is sort of unusual normally. So all these types of accelerated tests normally is used as an indicator. Okay, so another type of test is called outdoor weathering test, right? So as the name suggests, it is placing the samples on the actual outdoor, right? To let the samples weather off using actual environment. Of course, this kind of outdoor weathering test has a certain limitation where it is dependent on the location. Meaning, if let's say your samples are exposed to, say, a marine environment, so it means that with the results that you get, if let's say it's good result or bad result, means that it will be good or bad in such environment. Also, if let's say the location is more of an industrial environment, then it is tested for that environment alone, right? So the result cannot be uh, uh, said to be true for other types of environments, such as, say, for example, rural environment, where it's generally not so corrosive, and vice versa. So this type of test, outdoor weathering test, normally takes between 1 to 10 years to see the effect, right? So and of course it depends on what kind of tests you're doing, but for corrosion tests, normally you can see some sort of reaction between this time span. And of course, aside from these so-called sample outdoor exposure tests or outdoor weathering tests, there are also another types of tests where we normally will do a study on a specific project site. So these kind of studies are what we call case studies, and we will actually go down to different types of building and examine the material performance in that specific environment. Right, so I'll share some of the pros and cons. Right, so for this test itself, so-called this case studies, it normally takes uh, from 10 to 25 years for us to actually have a significant understanding of the building, and also to go back and do all these studies. That's why the effort to be spent is actually more, because we actually have to keep all the data of all the past projects and then actually go back and do all the studies. All right. So another thing you have to understand between the outdoor weathering test is that there is actually a standard that's established to determine the corrosiveness of an environment, right? So the reference code is called ISO 9223. It's actually an international standards document. And this document itself will establish the corrosion of different types of metals based on different types of environment, right? At the end, at the so the conclusion for this standard is that they will actually classify different environment into these 6 different types of category, from all the way from C1, which is not corrosive, right? Typically refers to indoor, and C2 is refers to outdoor but not so corrosive, and all the way to CX, which is extremely corrosive, and which typically refers to offshore or even industrial activities where internally there's a very high corrosive emission, and everything in between. So just to share with you about the standards itself, uh, different categories. So they actually use base different metals, for example, carbon, steel, zinc, copper, or even aluminum, to um, to be exposed in different types of environment, and based on their studies, they categorize, okay, if let's say carbon steel corrosion rate is as such, then it is considered as C1 or C2, depending on the environment. If let's say, for example, zinc or even aluminum placed in certain location, it has a corrosion of a certain rate, right, based on this table, then it will be classified as certain corrosivity category, I mean the environment itself. And let me just remind you, because I've heard this before from someone. This in this case, zinc here does not mean galvanized steel or so-called GI, right? Zinc here means a solid zinc block, right? It is the corrosion of this one is very different from a galvanized steel, where in terms of galvanized steel, the reaction is faster because you have an effect of the galvanic reaction. So this table itself will not be directly correlated to the galvanic reaction rate. Okay, so just have that in mind. All right, so it's just meant to use to classify the corrosivity of an environment. All right, so of course, if let's say you don't have such resources to actually expose all these samples in such site, then they actually have developed an equation to give you an estimate about the corrosion rate of your environment based on the 4 factors here, right? These 4 factors includes temperature, relative humidity, sulfur dioxide deposition, and also chloride deposition, right? So we'll go through this one by one to give you an understanding of what all these factors are. And in essence, these factors, you do not need to really use it to calculate, to calculate out the corrosion rate in order for you to understand. You can actually, based on your understanding of the environment, based on your observation, you are able to guess how corrosive is the environment, right? So let's start by classifying into these 3 key elements, right? Temperature and humidity are not escapable, right? So typically these two are closely related because of different geographical location, right? And of course, industrial pollutants and salinity, which refers to seawater, right? So historically, there are, of course, attempts to actually classify, the climate, right, based on climate data and whatnot, right? So the first one I would refer to is the time of wetness, right? Time of wetness means how much water or how much precipitation, which means rain, are there in a region. And as you can see, if let's say we zoom down to Malaysia, it is one of the highest or wettest location in the world, and hence, the more wetness or the more time of wetness and also humidity, then the corrosion rate will be faster in this region. Of course, same for temperature. So temperature, will also affect the corrosion rate, because higher temperature typically refers will mean faster reaction. Okay, so aside from just the time of wetness, there's also UV irradiation intensity, which means how much of the UV radiation is one location is exposed to. And here you can see Malaysia is not so severe, but in Australia, for example, or in South Africa, these regions are where sun intensities are at the highest, right? So these locations typically we would observe for the paint durability and so on. And of course, all in all, you can also use the type of climates to actually so-called estimate the time of wetness and also temperature. And over here, you definitely can see that Malaysia is considered an equator zone, where it's considered a tropical climate. So the time of wetness and temperature is always constantly on the high side, right? So that gives you an idea of time of wetness, and also temperature and humidity. So for industrial emission, typically pollutants that are considered industrial is so-called sulfur dioxide or SO2. So these can be from burning of fuels and so on. And sulfur dioxide is typically emitted from coal burning and whatnot. And as long as you have any industrial activities, normally sulfur dioxide will be emitted, right? And why this is corrosive, sulfur dioxide, is because if let's say you recall in your high school, sulfur dioxide reacting with rainwater will give you acid rain. And this acid rain itself will not be very obvious, at upfront, but on long-term basis, it will actually comes in and give an effect to whatever components that you have. And for example, like roof and whatnot, you will not feel the effect in the short term, but in long term, yes, right? So of course, in the standards that I mentioned earlier, ISO 9223, they also attempt to classify, for example, in a certain location, what is the uh, es estimated sulfur dioxide emittance, right? And of course, this is just for your knowledge, right? And historically, there has been also a mapping for all these sulfur dioxide emission. And what you can see from here is that part of the whole, part of the world, China and also India is considered to have a high sulfur dioxide emission. And this is probably due to the, the burning of coals, right? Because there are more coal power plants, back in China and India compared to other parts of the world, right? So that contributes to the emission of sulfur dioxide, right? And the last pollutants, also called influence to the corrosivity of an environment, is the level, pollutants level from salinity. Salinity means saline water, which also means salt water in layman's term, right? So salt water, why this is corrosive is because of the chloride that is contained within, which is salt particles, right? So this we actually covered in our previous webinar, where we talk about the influence of common influence of say swimming pool or even glove factories, and also sea water, right, where all of them has a common ingredient, which is chloride, and that will actually influence the corrosion rate of all the outdoor components, right, not just metals. Okay, and of course the standards itself also attempts to classify, okay, different types of chloride deposition rate. Okay, and historically there's also an attempt to find out about the salinity exposure of different part of the world. And what you can see from here is that normally they do mapping around the coastal region, okay, because that is where most of the salt exposure will be, right? So what you can see from here is that the region, the whole of Australia itself is actually surrounded by sea, and most of the region is considered corrosive because of its exposure to all these big ocean without any blockade. Like for Malaysia, we are still lucky because we are actually blocked. The strong pervasive sea wind is actually blocked by our neighbor of Indonesia and also Philippines. So yeah, so that defines the salinity influence towards the corrosion rate. So aside from all these three main factors, or so-called three key elements, there are actually small other elements that are considered corrosive. So typically these elements are from activities, from industrial activities and urban activities and so on. So let me just give you some examples. For example, nitrogen dioxide, which is emitted from fuel burning, right? So in internal combustion engine, like all that we have in Malaysia, right? So those gives out nitrogen dioxide, which will contribute to the corrosivity of an urban area. Okay, so that would eventually, be more and more severe if, let's say, there are more cars on the road, right? And hydrogen sulfide. So this is basically from micro bacteria that is breaking down all these feces from let out from, say, for example, cow and whatnot, right, chicken and whatnot. So the breaking down of all these byproducts will actually give out this hydrogen sulfide, which is considered one of the corrosive components in the standard, right? And that could influence how corrosive is an environment. Okay. And of course, not to mention ammonia, right? So ammonia is typically used for farm, right, to fertilize the plants or the crops and whatnot. And this component itself is very corrosive because of its reactivity towards a lot of different metals. And we have also covered this in our previous webinar, and you can actually check that out, right? So all these different components itself will be contributing to a corrosivity of an environment. Okay, so a trivial fact is that the term API, right? Air pollution index. So this typically we look to API if, let's say, our neighboring jungles are burning, right, and it lets out all these particles or smoke, right? So one interesting fact is that this API is not just calculated from the air particles, also called smog, right? It is also taking into account of the corrosive substance that I covered earlier, which includes sulfur dioxide, nitrogen dioxide, carbon monoxide, and also the ozone air particles. So all these, including the smog particles, is used to calculate the API index, so-called air pollution index, right? And interestingly, you can actually go on, for Malaysia, you can actually go onto the government's website, and there'll be actually a live update of all the locations API. And of course, these are just live location. It does not mean that it will be constant throughout the year. The standards that I show you, which is ISO 9223, it actually collects data for the whole year, and then from there they actually estimate the corrosivity of an environment. Anyway, so far for Malaysia, there's no such attempt that I know of that does this classification in specific region. So that's why typically we only look towards the distance towards the sea, right? So again, come back to the classification in the ISO 9223 standards, where they actually attempted to reference, also called correlate, what is the sulfur dioxide emission, typically what is the based on the category of corrosivity, what is the sulfur dioxide emission and and other influence, right? So, and in Malaysian standards, for coated steel standards, we also attempted to reference back to this ISO 9223, where we actually give a much more simplified and more visual sense of what this classification would mean to different types of environment. So, for example, C4, which would normally mean moderate SO2 exposure and also moderate salinity, right? So, how is this useful or being used in our method is actually through accelerated tests, right? So, which leads me to today's comparisons, also called topic. So I will be covering 4 different types of tests. So 2 accelerated tests and 2 outdoor weathering tests, right? So the first one is called source spray test, and I'm sure some of you might have heard of it or are familiar with it, but I think what I would like to mention is that based on my study of this standard, also called this test itself, it is actually used as to induce corrosion of the samples, right? So like I mentioned earlier, inducing corrosion of the sample is not really used as a simulation to indicate how the samples will react in the actual environment, right? So the reason why I say that is because referring back to the standards, right? So throughout the world, right, this test itself has been standardized as a testing method, right? So, for example, in United States, right, they actually established this ASTM B117 as the test method for salt spray fog, right? And for Australia, they use AS2331.1.3.1, and is referring to as neutral salt spray test. And in international standards, is ISO 9227, okay, again, salt spray test. And the test setup is more or less similar, where you have to actually focus on this location, right, where the samples are placed, and the salt fog are actually sprayed into the air instead of directly, and creating a salt fog environment, right? So based on different types of experts referencing to these standards, what they mention is that salt spray test results in general do not correlate well with the corrosion seen in actual atmospheric exposure, right? So, and also the performance of natural environment has seldom been correlated with salt spray results, because the corrosion performance based on exposure to the test environment provided by the practice are not always predictable. Okay, so that what it means is that the test result from salt spray test cannot indicate or so-called be replicated in the actual environment. And you have to ask yourself, in this case, which result is much more important, the actual results or the salt spray test result, right? So, and just now the reference standards that I mentioned, AS2331.3.1, it also mentioned that it's important for the result obtained from tests are not regarded as having a direct correlation with environments in which items may be exposed in service, or as indicating the relative corrosion resistance of different coatings. So what this means is that, if let's say you put two different samples in the same salt spray chamber, right, the environment that I mentioned earlier, and then put it through a certain duration of testing, for example, 1 month. If let's say you get a result that says sample A is good, sample B is not so good, it does not mean that sample A will perform better in actual weather compared to sample B. Okay. And ISO 923, another salt spray standard that I mentioned earlier, they are not intended to be used for comparative testing as a means of ranking different material relative to each other with respect to corrosion resistance. All right. So even the standards that actually guide you through the testing itself actually has a note that says that you should not use this to make a comparison between two different materials in terms of its performance or its corrosion resistance performance. Right. So that is a very important message. Okay. So why are people still using salt spray test as a comparison, right? So that is the question that we have always need to we have and we need to ask ourselves. And of course, one guess that I would have is that people have been using salt spray tests before any other things are available to simulate or so-called to induce corrosion. That's why people have been going back to these standards, and there was not much awareness about what other options are there, right? But today, let me just share with you, what is salt spray test and why I think it's not realistic, and what other options can you look for, and you need to demand for it, right? Because in our market, I'll share with you, is more on when consultant asks, only it will be provided, right? If there's no demand, people will refer back to the old testing methods. So it's important that you demand for it. Okay. So salt spray test itself is actually very simple. So you just put the samples into the chamber, then you set it up to such environment where the salt solution salt port itself will contain 5% of nitrogen chloride. Sodium chloride, which also is refers to as salt, right? So 5% of salt solution being sprayed into the environment, to the chamber, and the environment should be in 35 degrees Celsius constant temperature. And one cycle typically would take 250 hours. That means the salt spray itself would take 250 hours to run one cycle. All right. So of course, if you look at this standard, this is for coated steel testing standard. So what they attempt to do is, correlate the salt spray test to a certain corrosion corrosivity category, right? But this again is not very reliable because this has been copied out from a very, very traditional testing method and also an old reference document without any which actually will imply that it's not really relating to an actual performance. But anyhow, what you can see is that if let's say your samples is tested to say 1,000 hours salt spray test, and pass certain criteria in the standard, then it can automatically be referred to as C4 corrosivity category product, meaning that product will be able to withstand in C4 environment. But you need to ask yourself, this short-term test, also called accelerated test of 1,000 hours, even though it's classified as C4, right? That means it can be put in, near the sea, right, on a building. But have you asked yourself, how long can it last, right? What does this 1,000 hours mean? Okay, so that is an important question. It can withstand in such environment, but for how long, right? So in actual fact, even us who study those standards, we are not able to tell you, and we do not dare to tell you because there's no standard method to actually estimate that. All right, so end of story for salt spray test. The results, also called the duration of test, has nothing to do with how it performs in actual weather, right? So I'll show you one example, which I will pull up this example again in the next topic, in the next point. So this is the same sample that's exposed to 500 hours salt spray, to 1,000 to 1,500 to 2,000 hours. So does it mean that it can withstand in so-called 1,000 hours, which means C4 category? Right, so that's the question, right? Anyway, so let me just share with you why I think salt spray test is not realistic. So back in, I think more than 30 years ago, there was actually this comparison done that shows, okay, the same sample, they expose it to external, meaning actual weather, and then they use the same sample and then they put it in salt spray test. And they did another variation of salt spray test, which at that time they called it corrosion test. It's a type of what we call cyclic corrosion test, right? So in simple term, corrosion and salt spray test actually has a very small difference, okay, which I'll get into later, right? So but just this to share with you first, corrosion test itself, it has a certain component of salt spray and it has a certain component of drying and also wetting. All right, so it's a variation of salt spray test. All right, that's all you need to know for now. But let's see, all right, with this variation, what it will present, okay, and why salt spray test is not reliable. So they actually put the one sample to external weather and one to salt spray and one to corrosion, right? So the salt spray and corrosion both are exposed to the same hours, 500 hours. In the exterior, different timing, all right? So after 4 years, they show that this sample itself, for 4 years on, there was no sign of deterioration, or there was just some sort of chip off or rusting at the cut or slit area. And then they look at the salt spray, 500 hours of it, actually indicated that it started rusting at the slash area. Basically, you can imagine it as a scratch. And then they look at the position. Okay? The position seems like it is representing closer to the exterior weathering sample compared to the source spray. Right? So this is just one example. They went on to compare another type of sample, different types of paint system, different types of substrate, right? So this one, they only exposed it for 14 months. Probably it's not so durable compared to the other one. Okay, so for source spray and also Corrosion, they tested it for 1,400 hours. So what you can see from here is that, again, Corrosion test seems to be showing a more realistic, also closer results compared, to the exterior exposed sample compared to the source spray. I mean, yeah, the source spray seems like is showing much more severe results. But again, which one is more important, right? Is it the exterior or is it the source spray? And last but not least, they exposed another sample, right? Where in this case, the exterior example, they actually put it for 4 years and then they did a slash. And then source spray, they just 600 hours and Corrosion 600 hours also. So in this case, it seems like source spray test itself is not really realistic, right? I mean, it constantly shows like the result is not tally with the exterior exposed sample, right? So you might think, hey, how about if let's say it's tested worse in the source spray, then it means that it has gone through and it hasn't failed, then it has gone through the most severe testing possible, and then in next year it shouldn't matter, right? So if you think that's the case, let me show you some other examples later on, so you can understand right where I'm coming from and why is it not true, right? So again, source spray test is self compared to Corrosion test. It has for Corrosion test is just source spray and addition of drying and wetting, right? So the element of drying and wetting is what makes a Corrosion test a different sample. So that leads me to a test that is similar to Corrosion test, but it's now what we call cyclic corrosion test, right? So cyclic corrosion test is very similar to Corrosion test in the sense where you do not just have a source spray, you actually have a drying and also wetting cycle, right? So now you imagine in your look out your window and whatnot. Does the weather constantly have rain? Right, the answer is no, right? So you have actually a drying cycle and also a wetting, which is like early in the morning where you have condensation happening or just normal misting and whatnot. So that is what cyclic corrosion is all about, right? Giving it a cycle, right? So of course in American standards, there's a reference to it for ASTM G85, and in Australian standards it's AS 2331.3.13. Okay, so of course there are actually different types of cycles, but the one that we end up choosing, which typically is used for outdoor, is this, right? So it will have actually salt fogging, which is the salt spray, drying off, and also the wetting, right? So in terms of the duration, it will have actually 8 hours per one cycle, right? It will have 2 hours of salt spray, okay, and then 4 hours of drying, and then 2 hours of wetting, right? So here you can see that it's actually 25% of it is salt spray of one cycle is actually salt spray. Okay, so again, so you have the salt spray, the drying, and the wetting. Okay, and in Australian standards, in Malaysian standards, we also started adopting this dual testing method. So there'll be a source spray and also a cyclic corrosion, right? So what you can see from here is that if let's say product, so this product type is also considered as a product corrosivity category. So if let's say the product can pass this source spray of 1001 and it actually passed this 2000 hours of cyclic corrosion, then it will be considered as C4 category product. Right, so it does not mean that if let's say it passed only one of them and it failed one of them, it can still be classified as C4. No, right? But in Malaysia, so it's a different case. Either you can opt for the source spray test, or you can actually opt for this cyclic corrosion test, right? So just now I mentioned C4 was 1,000 hours source spray test, right? So now cyclic corrosion is C4 2,000 hours, right? So the so-called salt spray duration of this 2,000 hours is actually shorter compared to the source spray test, right? Meaning the source spray duration of 2 hours per one cycle of 8 hours, it will be shorter than the actual source spray of 2,000 hours. So here is the result for comparison. So cyclic corrosion of the exact same sample that I showed you earlier, 1,000 hours, 2,000 hours, and 3,000 hours, right? And so I pull back the 1,000 hour sample from earlier, right, of source spray and cyclic corrosion. So what you can see is that having incorporated the drying cycle, it actually makes the sample corrode more, okay, not less, okay? So it will actually make the sample corrode more, all right? So having a long duration of source spray doesn't mean that it is always the worst case scenario, okay? You actually need to incorporate certain actual element, which is drying and wetting, to make it corrode in a faster way. All right, so this is 2,000 hours of source spray and also 2,000 hours of cyclic corrosion test. Both are actually the same material. All right, and at the end of the day, you can still see cyclic corrosion seems to show a much more severe result. But does it matter at this point? Which one is more severe? If let's say you can't really simulate the results closer to the actual performance, the answer is no, right? So hence the third point, right? Of course, different manufacturers have different attempts or different methods of doing it, but they're actually standard established to guide us through how to actually set up the outdoor weathering tests, right? So in simple hindsight, how outdoor weathering test means putting the sample in different outdoor environment and leaving it there for certain durations to test for its durability in terms of pain, in terms of corrosion. And of course, these samples needs to be maintained, meaning it needs to be guarded to make sure that there was no manipulation or so-called other unintended influence, like sample removal, sample being blocked by certain components, right? Or protected or so-called damaged by certain components. And of course, the photos that you see here is actually set up in our factory in Kappa, right? And in actual fact, it is not just set up in our Kappa, it is set up throughout our BlueScope facilities, our factories. And of course, in because the standards that was established is based in Australia, and so this test sites itself, it can be classified in different locations, and different locations itself, they also have rated the corrosivity of that location based on ISO 9223 guideline. So what you can see is that different locations as shown here, it actually has different corrosivity category. And I would like to highlight this Muriwai, coastal Muriwai, because I will be referring to it for my outdoor exposure results later. And of course, for BlueScope, we actually maintain more than these 3 sites, but these 3 are the one that was registered or so-called being recorded in the standard, right? Bellamy Point, which is C4, Shell Harbour, which is C3, and then Port Kembla, which is C5. Typically refers to a more industrial setting, right? So aside from that 3, have Buriwang, which is more rural, less corrosive area. C3, Shell Harbour. C4, Bellamy Point, and C5, Port Kembla. Right, so a C4 environment or test site would be literally just next to the sea, where there's actually a prevailing a strong sea breeze. Right, so of course, if let's say the product itself needs to be withstanding a certain severe UV exposure, then you expose it to Rockhampton, where we actually ran a test site there, and the UV exposure in that location is one of the highest in the world. And yeah, we typically test our paint durability over there. Right, so just to show you some of the examples of these outdoor weathering tests. So same sample being placed in 3 different test sites, C2, C3, and C4. What you can see is that, the severity tends to vary, right? So being C4 having the most severe result, right? And so this comes to where I will compare, right, the actual outdoor weathering test versus the accelerated tests, right? So just now I share with you soft spray test and the cyclic corrosion test. So what you can see here is two samples of the same DNA. Actually, it's the same sample that was placed in one in outdoor C4 environment, relied, as I mentioned earlier, which is near the sea, right, very corrosive, and one in the soft spray 2000 hours, right. So what you can see is that the outdoor exposure test sample showed a very, very severe result of rusting and paint blistering and whatnot. But the source rate itself is not showing anything after even 2000 hours, which in this case would be classified as C5, right, category. But if you look at the cyclic corrosion test, it seems like, hey, 2000 hours, which typically is referred to C4, which is the same so-called classification as Muriwai. It seems like, hey, it's showing closer result to the Muriwai test site sample. I mean, the exact same sample. So this gives you the answer, right? Which test is much more realistic, right? Of course, in this case, it's clearly the cyclic corrosion test is much more realistic compared to the soft spray test, right? But of course, if let's say you have a result of the exact specification of the product in the exact type of environment, right, that you are gonna use the product in, then it'll be the best, right? But most often, it's not very ideal, right? I mean, we can have all the results from Australia and different part of the world, but sometimes people will ask, hey, it's not Malaysia, right? So why not you just show us some more realistic example? So of course, that's what we have been doing in BlueScope, and of course we are still doing this aggressively with the help of our customers and also extended network. So the last type of test is called project site case study, right? So of course the previous samples, as I mentioned, right, has sites outdoor weathering. It needs to be guarded. It needs to have minimal kind of influence from, say, that being damaging or being protected to influence the result. And even for the accelerated test, the first question that you need to ask is, how legit is this result? How is it going to be reflected in the actual weather? How do I translate that into actual result? So and also not to mention how manipulatable it is, right? The salt solution, it can be manipulated. The temperature, like how consistent can it be? So all that leads to this project site case study. Why we do this is because it's hardly manipulatable because because of the scale of it. So that's why we typically refer to project case studies instead of just the accelerated test or even the outdoor weathering test, right? So let me just share with you some of the lessons that we have learned from some of the case studies that we have done, right? So out from the start, we actually studied not so corrosive area, right? Where this shelf lot itself, we received this from a complaint. It was actually rusted after 5 years in a rural area, in a not so corrosive location, right? Somewhere outskirts, somewhere outside of the industries, right? So this building itself has started showing, I mean, the roof has started showing corrosion after 5 years. So this exact photo itself is taken after 5 years of the building, I mean, of the roof is not on top. Of course, this result itself is not ideal, and typically it is not expected to be, right? But why this happened, right? So this, of course, is not our material, but why would people believe that this product can last long and then use it, right? Probably because they were referring to a source spray test. Can it be? Right? I mean, these are just some of the possibilities, right? Can people be overconfident about a product by having it tested by a reputable test facility to a certain standards that it has been established but never proven to be right? And the terms so-called the source free test has also been repeatedly saying that it's not reliable to be used to show an actual performance. So, but out there, people are still being misguided by this source free test, right? So in the end, is it because of that caused people to buy into products that are not durable? Hence, this happened, right? So those are the things that we found out, right? Because of that, this happened. Okay, so of course, uh, compared to that, there's a adjacent building that was actually using more durable product, right? And both are installed in the same time, and one seems to outlast the other, right? So both are claiming to have so-called more than 10 years durability, right? But one falls short of another 50% of its lifespan. So so this shows you the impact of having an actual project case study, right? So of course, having done that, we also did studies in different environments. For example, in this so-called resort that is right on top of the beach, right? So this resort itself has been built for 5 years, and on the 5 years point, we also went back and did some shootings to understand better, how is it performing and whatnot, right? So this environment can easily be considered as a C4 environment because it's just on top of the seawater, right? So, right, from the photo itself, you see that it's not showing any types of corrosion, and this will be a very so-called a very strong message to tell you that this is not manipulated, right? And it has been tried and tested in the very specific environment. If let's say you want a building to be built near the beach, right? So this is a solution that kind of give a direct message compared to say having to explain source spray test and how to correlate that, right? Those are, as I mentioned, are always misguiding, right? So another location that we recently did another study is airplane hangar. So this building has been there for 12 years, right? And it's actually an airplane hangar. So what it means is that it will have exposure to nitrogen dioxide and all the fuel burning pollutants. Okay. So after 12 years, we actually went back and did an observation. Of course, in this case, we are not expecting any types of corrosion because it's not expected to happen. But what we saw is what were looking at is actually more of the color performance, because in this area is also quite vast uninterrupted location where it is exposed to mostly sun and rain, right? So you want to see the color performance, and after 12 years, this is the result. We actually brought an original sample and compared side by side, right? So that is what project case study can do compared to an outdoor weathering test. So this kind of show you a direct result of how much have the color changed in actual Malaysia weather. Right, so the last example that I'll show you is this Beachside Aquarium. So of course, this building itself, facade, the roof are actually built with the material. And after 15 years near the sea, because it literally is just next to a beach, so it shows a really, really good weathering effect without any sign of corrosions on the surface, right? And so this shows also for proof directly that the product can last in that environment for 15 years, right? Direct correlation, right? And of course, having done those different types of studies, we also took the opportunity, right, to actually study the intricate part of the building, right? So different parts of the building had different detailing, different design, and we also took this chance or took the activity to the next level. Instead of just studying about the actual performance, we also take this chance to gather more data to provide it back to the client or to whoever will need it in the future. So in this case, or most cases where the building itself is located near an industrial emission, also called marine emission, is that we look at the effect of accumulation. What we mean by this is that there is always in areas where the material itself is exposed to external elements like all these fumes or all these gaseous emission or so-called saline water or saline salt water lah, basically, but it's not being exposed to rain to dilute it or being wash it away. So these areas, typically we call them unwashed areas. And this effect of accumulation means that these areas which are unwashed, even though it's exposed to external elements, it will actually accumulate all these pollutants and have what we call localized corrosion, right? So one of the buildings that we studied in this example is that it's actually a salt manufacturing plant and basically salt producing plant. So what happened was that the salt itself, some of the fine salt actually got airborne and actually accumulated onto the structure near the cladding. And what you can see from this small photo is that the cladding itself and also the structure actually has started reacting with salt particle. So because it's not being diluted away, right? And in this kind of production, you don't want to dilute away because if let's say you get water into salt, the yield of the salt will be less. That means you'll be producing less of the salt, right? So, but having said that, that is the effect, right? Effect of accumulation. It will actually cause corrosion, right? So some other side observations that we have done also is, effect of scratches on coated steel, right? So most often people are always concerned about, hey, there are scratches, unintended scratches from different kind of contract workers or construction workers and whatnot. And how do I address that? Do I paint over it and whatnot, right? So sometimes you shouldn't just be quick to give a solution. So we always have to consider the pros and cons, right? What would be the pros of painting it, covering it? Right? Would it be good? Will it look good, right? But if we don't touch it, we don't cover it with another additional layer of paint, what will happen? So we actually study, what is the thickness that will cause the effect of corrosion, what will not. So in this case, this scratch itself, even though it has actually shown corrosion, but this is after 12 years. And the scratch itself is actually kind of minor, right? So after 12 years, you actually don't see any penetration through this roof, right? So those are the things that we can actually collect from this project site case study to give back more value to, for example, designers, to project manager and whatnot, so that we can give a much more confidence about certain product or certain specification, so that they will make the right action or so-called informed decision. Right. So with that, today's topic, we have covered 4 different types of tests. Of course, before that, I've shared why do we do accelerated tests, and of course, what influence corrosivity of an environment. So that follows the ISO 922P standards to classify an environment, be a C1, which is indoor, C2, not so corrosive, all the way to C5, C4, C5, and CX, right? So, of course, the 4 types of tests that I've mentioned, clearly I, concluded that source spray test is not to be referred to or compared with other types of source spray result, because it, as the standard itself has already mentioned, it's not reliable to be used as a correlation to the actual performance, right? So of course, I also did a comparison between source spray tests and cyclic corrosion tests, where it shows that cyclic corrosion tests seems to show a much more correlation or closer results to the outdoor weathering test, which should be the benchmark, right? And of course, for people who are looking for convenient answer, you should not always look for source spray tests. You should look for the project studies or project case studies, or even the outdoor weathering tests. Those are the ones that you'll be able to easily correlate to your environment. If let's say it's the exact same environment, for example, if you know that your building is built near the sea, right? So roughly you can estimate that it's actually C4, C5 environment by the standards. Then you can do a study and right? So for example, C4 environment near the sea. Right, if let's say certain companies come to you or supplier come to you, say, hey, my samples has been exposed to this outdoor, which is classified C4, and this is the result. Then you can get the direct answer from them. Instead of, hey, my material has been tested for source spray test, and this source spray test has been classified C4. Do not trust that result, because that is quite misleading, right? And last, if let's say you have, of course, you can ask for case studies of, that same specification in, say, near the sea. If let's say they can't provide you, that means, either they don't have that material that can last. That spec itself cannot last in that long in that environment, or they have not done such tests. And you can always push for it, so that eventually this data is available for you to make an informed judgment. All right, so we are available on our website, YouTube channel, Facebook, Instagram, and also LinkedIn. Right, so you can also email us in events@bluescope.com.my. And with that, I'd like to conclude today's session of Still Connect webinar, and see you guys next time.